In this video, we'll demonstrate the use of remote functions which enable custom logic in BigQuery SQL queries. In the video description, you can find a GitHub repository link with all the code that we use throughout the demonstration. Let's very quickly create a diagram for what we're trying to achieve, and then we'll jump into the Google Cloud Console and demonstrate an example setup. While BigQuery and Cloud Functions are really the stars of our show, we'll be using identity and access management to set up a secure bridge between them. Alright, so let's implement this now in the Google Cloud Console. I'm going to use two browser tabs here, one for BigQuery and one for Cloud Functions. In the first tab, let's navigate to the SQL workspace. As you can see, we have no existing data, so we'll create a dataset and import an example CSV file. We'll call the dataset users and choose a multi-region US setup. Within that dataset, let's create a new table. I'll import from Google Cloud Storage in the demonstration, but in your case, you'll probably want to download the CSV file from GitHub and then choose the Upload option for creating the table. We'll call this table Purchases and auto-detect the schema. I'll also note that this is just fake data for demonstration's sake. We won't be exposing any real information. Great. So the next step is to set up our Cloud function. Let's jump over to the second tab for that and search for Cloud Functions. Let's click to create the function and enable any required APIs. We'll use the second generation environment and call this function bounded mean. Our example remote function code will be based on a differential privacy algorithm. If you're not familiar with differential privacy, that's not at all a problem. We'll just use that as an example and you'll be able to follow along regardless. When I click Next, it's going to ask us to enable a few more APIs. If you're following along in an existing project, you probably won't need to enable so many APIs, as you'll have a lot of them already enabled. We'll do Python 3.9 for our cloud function, but of course, feel free to play with other runtimes. For the code, I'm going to paste in the code from the GitHub repository here, and then change the entry point to entry point. So what we're doing here is calculating a bounded mean using the PyDP differential privacy library. The bounded mean uses Laplacian noise over a standard mean calculation and in the process improves the privacy of the underlying data. We've also included the BigQuery client here in case you'd like to add any data checks or subqueries. When we get our request, we'll pass the input data through our bounded mean function and return a rounded output. In the Google Cloud documentation, which is linked in the description of this video, you'll see the exact request format and the required response format so that BigQuery can use this function. Before we deploy, we'll also need to update this requirements.txt configuration to include the custom libraries that we used in our function. Again, the BigQuery SDK is not strictly necessary, but it's interesting to experiment with not just how BigQuery can call into Cloud Functions, but also how Cloud Functions can call BigQuery. We directly use this differential privacy library, so in any case, be sure to include that one. Let's go ahead and deploy. This is going to take a minute or two to deploy. While that's deploying, we can go ahead and set up our connection to the Cloud function in BigQuery. So we'll go to Add Data and create a connection to an external data source. This will require yet another API to be enabled. Once that has successfully been enabled, we can click to create the new connection. The Cloud function is going to fall under this last category of Big Lake and Remote Functions. Let's call that connection ID bounded mean and accept the defaults for the rest of the fields. We now see that connection showing up in our external connections here. If I open that up, we can grab the service account ID for some permissions setup. Without giving this service account permissions to invoke the Cloud function, our SQL queries will fail. The permission setup will be in the Cloud Functions interface, so we'll wait for this to finish up and then add the required permissions here. Okay. With that service now deployed, let's go to the Permissions tab. We can see this warning about needing to add invoker permissions, and we're given a handy example command. The permission setup is a little bit different for first-gen versus second-gen Cloud functions, but the templated help commands will help us in either case. So, in a Cloud shell, let's go ahead and paste this command. We'll use that service account from earlier, and we'll also need to specify that this is a service account using a prefix. It looks like we need to specify the project ID. No problem. Okay, so this was successful. We've added the required permissions and can now navigate to our BigQuery SQL workspace to create our remote function. Again, all this code is available in the video description. To fill out this function creation command, we just paste in the Cloud Functions URL from earlier. We see that this should go through successfully, so let's go ahead and run it. Alrighty, and that looks good. Now let's use a new query window to actually use that remote function. For a better understanding of our upcoming queries, let's quickly check out the data that we imported earlier. Again, this is completely fake demo data. We'll be using our bounded mean function to calculate a bounded mean for these total purchases. We'll do that in a way that improves the privacy of the underlying data. Okay, let's see that. We'll run a command of this format and just need to pass an array of total purchases to our function. When I click Run, we'll get some results back and see that the bounded mean is 328. Now we can actually compare that to the mean in the traditional statistical sense. The mean is about 304. So you can see that this bounded mean is close to, but not exactly equal to, the actual mean. We've introduced some noise into the aggregate calculation. In any case, we've now seen how to use remote functions in BigQuery. This gives us a lot of power. We can have Cloud functions written in languages like Go, Python, or Java, and then use those functions directly in our SQL commands. This is especially valuable for non-developers that are only comfortable with SQL, but want to use your custom data processing algorithms. The demonstration today is generalizable to a very wide variety of use cases for BigQuery and Cloud functions. We hope you enjoy using this architectural pattern, and we'll keep an eye on the comments for any questions. Thank you for watching.